Good morning, everyone. I am Khemraj Meena, currently pursuing my bachelor degree in aeronautical engineering from University Department, Rajasthan Technical University, Kota. Today, my topic is James Webb Space Telescope under the guidance of Professor Mohammed Shai sir. So let's begin with the first slide. So this is the content of my seminar. So let's begin with the introduction. The James Webb Space Telescope is one of the largest and most complex science program. Is designed to answer questions about the origins of planets, stars, galaxies in the universe. The James Webb Space Telescope is a space telescope designed primarily to conduct infrared astronomy. Webb is built with an innovative technology to explore the universe behind the Hubble and Spitter's Reach. It was launched on 25 December 2021 with a cost of 1,000 crore USD with launch mass of 6,161.4 kg. The mission duration is 20 years accepted and 10 years is planned. The James Webb Space Telescope is an international collaboration. The NASA has collaborated with European Space Agency, Canadian Space Agency, and the manufacturer of James Space Telescope is Northrop Grumman and Ball Aerospace and Technology. The Space Telescope Science Institute will operate Webb after the launch. The James Webb Space Telescope has four scientific instruments. The first, the Near Infrared Camera, NIR cam. The second one is the Near Infrared Spectrograph, NIR specs. The third one is the Near Infrared Imager and Slitless Spectrograph, NIR-ISS. The fourth one is the Mid Infrared Instrument, MIRI. So let's start with the first instrument, the Near Infrared Camera, NIR cam. NIR cam is the Webb workhouse imaging instrument at the near infrared wavelengths. It offers significant gain over the high resolution camera on the base telescope. The instrument has a dual model that independent and returns, and each point is adjacent field on the sky separated by 44 arc seconds. Each of the NIR cam detector has the sensitivity from lambda equals to 0.625 microns. NIR cam chronography is expected to be used to discover exoplanets and for the study of the bright central region forces such as active galactic host galaxies. Now come to the second instrument, the Near Infrared Spectrograph, NIR specs. NIR specs is Webb spectrographic instrument at the near infrared wavelength. The instrument has a sensitivity over the broad wavelength range of lambda equals to 0.6 to 5.3 microns. NIR specs offer three distinct spectroscopy mode: single spectroscopy, integral field spectroscopy, and multi-object spectroscopy. Spectroscopy with NIR specs in its lowest resolution mode are approximately 100, utilize a prism with the sensitivity over the full lambda equals to 0.6 to 5.3 microns wavelength range. A spectrograph, also sometimes called the spectrometer, it is used to disperse the light from an object into a spectrum. Now the third instrument, the Near Infrared Imager and Slitless Spectrograph, NIR-ISS. NIR-ISS is a near infrared imager spectrograph and the interferometer with the sensitivity over lambda 0.5 to 5 micron. The spectroscopic capability of NIR-ISS include both single object and wide field slitless modes. NIR-ISS slitless spectroscopy is expected to be used for observation and require high precision and spectrometric stability. FGS is a guide which helps point the telescope. NIR-ISS will be used to investigate the following science objectives. The first, light detection. The next one is the fourth instrument, the mid-infrared instrument called MIRI. MIRI is a versatile instrument that extended Webb sensitivity into the mid-infrared wavelengths. Four core capability of MIRI is photometric imaging, low resolution slit or slitless spectroscopy, medium resolution integral field spectroscopy, and chronography. MIRI is cooled to 6.7 degree Kelvin with an electric cryocooler. The sensitivity range of MIRI is designed to start where the near-infrared cameras ends. The chronograph can also be used to study debris and AGN host galaxies. Now we will come on the commissioning of James Webb Space Telescope. Commissioning James Webb Space Telescope is complex, a 6-month process. JWST unfold a tower extended. The secondary mirror supported unfold 6 of the 18 primary mirror segments. JWST cooled passively, and 40 to 50 Kelvin telescope and science instrument are isolated from the 300 Kelvin spacecraft. JWST is thermally demanding. Commissioning of JWST for the first month. An Ariane 5 will launch James Webb Space Telescope to L2 Earth-Sun Lagrange point. 30 minutes after the launch, JWST will separate from the launch vehicle. The solar array will deploy the get power. The less than a day after a launch, JWST must burn a mid-course correction to send it toward L2. In the first 2 weeks after the launch, JWST will deploy the tower, the sun shield, and the secondary mirror and the wings of the primary mirrors. 2 weeks after the launch, primary mirror segment will slowly rise from their stop position. The next one is the innovative technology in JWST. It has an advanced folding and segment primary mirror. It has an ultra-lightweight beryllium optics. It can detect extremely weak signal. Microshutters. Microshutters are a new technology that was developed for the James Space Telescope mission. There are the basically tiny window with a shutter. Each measure 100 by 200 microns. And the next one is cryocooler. So now we're going to discuss about the 4 main purposes of James Webb Space Telescope. The end of the dark ages, the first light and reionization, the assembly of the galaxy. The next one is the birth of stars and protoplanetary system, and the origin of the life. Now the infrared range. Webb instrument will designed to work primarily in the infrared range of the electromagnetic spectrum with a capacity in the visual range. It will sensitive to light 0.6 orange to 28 microns meters in wavelength as shown in the figure. Infrared range for JWST instrument. The near infrared range, cooler red stars dust is transferred. At the mid-infrared range, planets and comets and asteroid dust formed by the starlight and protoplanetary disks. Now we're gonna see James Webb Space Telescope versus Hubble Space Telescope. The JWST is the size of a tennis court with a distance of 930,000 miles, with a weight 6,530 kg, with a length 72 feet, and it operates at temperature 40 kelvins. Hubble Space Telescope is the size of bus and has a distance of 350 miles only. The orbit times is 97 minutes with a weight of 11,600 kg with a length 43.5 feet. Now we're going to discuss the advantage of James Webb Space Telescope. James Webb Space Telescope is powerful as Webb is the successor of Hubble and it's 100 times more powerful time. Webb also have much bigger mirror than Hubble. Webb will also be 1.5 kilometer away. With the Webb, it will be possible to see back in the time to the earliest object in the universe for the first time. We will be able to characterize other planets going around the stars. And it will also help us to map the universe. And it will investigate the nature of dark energy in the universe. Finally, we come to the conclusion part. The conclusion, JWST is the National Academy of Science top investment priorities for NASA space astronomy is decaded. It is a model of international cooperation and collaboration. It continues to thrive under a philosophy and demand clean centralized management and a strong system engineering. JWST will inspire the lives of thousands of scientists and engineers. Is there any questions?
Yes. Why Lagrange point L2 for James Webb Space Telescope?
L2 is located 1 million miles from Earth. The telescope optics and instrument need to be kept very cold to be able to observe the very faint infrared signal to very distant object clearly. The location is perfect for Webb, essential to block a light and heat from the sun, Earth and the moon, making L2 is thermally stable location for the observatory to operate at.
How does MIRI cooler work and why it requires?
It is a heat pump consist of pre-cooler that generate about 1/4 watt of cooling power at about 14 Kelvin using helium gas as working fluid, and a high efficiency pump that circulates refrigerant, also helium gas, cooled by the conduction with the pre-cooler to MIRI. Where MIRI instrument carry a detector that need to be at the temperature of less than 7 Kelvin to operate properly. This temperature is not possible on Webb by passive means alone. So Webb carry an innovative cryocooler that dedicate to the cooling MIRI detectors. This is the reference, and thank you.